Welcome everybody on today's webinar, Build Your Product Today with 3D Perception. My name is Dariusz Kominiak and we will start in a couple of minutes. Let's give a moment for everyone to join our webinar today. Let's start. I believe most of the attendees already joined. As I said before, my name is Dariusz Kominiak. Topic of today's webinar is Build Your Product Today with 3D Perception. And I will show you what a FlashEye as a company has created and what you can get as a already existing product and integrate with your portfolio and get 3D perception directly into your products with very little effort or sometimes even no effort. Starting with our vision is being, of course, number one preferred software partner for stationary 3D Lidar perception by offering a fast track to high valuable data streams, and of course, eliminating accidents and costly failures that could have been avoided if detected. This is our vision, and on the right side of the slide, you can see a point cloud, something which you will see quite frequently today. This is a data coming from the 3D LiDAR, a sensor which is more and more popular nowadays. It's getting great attention, and the best out of it is that every point you can see on this point cloud has dimensions, the position, X, Y, Z, so you can utilize this information in various ways, and by using perception software you don't have to create everything on your own. You just utilize metadata which is created by perception software. Shortly about the FlashEye, it is a Swedish company developing advanced LiDAR perception software and analytics. We are successfully commissioned several big projects and solutions in mining and heavy industries in harsh conditions where our environments very challenging for other technologies. And currently we are focusing on mine, port, security and ITS applications. The LiDAR solutions within safety and security for people and vehicle tracking, counting and analytics, and real-time monitoring with advanced LiDAR perception. And we believe that the LiDAR, introducing the LiDAR perception into the many different parts of industry or smart cities or even like autonomous cars, will enhance safety and efficiency. And this is a great step towards autonomy. As you can see on the left side of the screen, this is showing traditional control room in some industrial scenario where there is usually a person looking at multiple camera streams, basically watching video streams, checking if everything is happening correctly, if there is no failures, if there is no accidents. And this is a risk. The person is just a human. Everyone can get tired after a while. The focus might not be at that day that sharp. And we believe there is a great room for improvement in this kind of scenarios with smart assistance systems, of course, where the smart assistance system initially can provide warning information where to focus the attention, where is the problem, where is potentially a problem, leading at the end to fully autonomous operations, where basically the infrastructure will operate on its own, and people will be basically notified on demand whenever there is some uncertain or some anomalies happening. And we believe that 3D perception is the enabler for such a scenarios where we can achieve this. Quick comparison between different technologies, because we are talking about lidars, but there are also radars and smart video. And every technology is great in some areas, but the areas where we are focusing our expertise, where we are promoting this lidar perception software the most, is where the other technologies have difficulties. Of course, it is always good to apply correct technology for correct task. And as you can see on this comparison table, lidar has both lidar and radar have great spatial perception and precision, where the smart video might be challenging in some conditions. Both lidar and radar provide great integrity for people. You can detect that there is a person walking by, but you don't need to worry that, or someone doesn't need to be worried that the personality will be recognized and identified. This is very important in some areas where we have unions in the companies, and they are not willing to accept the cameras watching the personnel working in this place. Cost-effective coverage of large areas, and lidars, same with radars, can cover big areas, especially when we think about lidars which are rotating and scanning 360 degrees around them. The coverage is really great, which might not be achieved with standard cameras by single unit. Of course, one can install multiple cameras and configure the system using multiple cameras from different point of view for different perspectives, but then the cost added not by a single camera, but all wiring and installation process and calibration process will not make it cost efficient. All-weather performance, and this is a parameter which is achieved by both lidar and radar. It does not matter if it's snow, it does not matter if it's rain. Both of those technologies will perform very well, much better than a video. One can say some technologies might struggle with fog, and also this is a lidar which might be difficult for fog, but definitely it is much better penetration than smart video. Handles metal and water. Sorry, this is something which radar technology will struggle. Lidar has no problem. Smart video might get a lot of artifacts and reflections from, let's say, even like sunlight casting on the water. Handles dynamic outdoor environments. This is something which lidar is great with connection with great perception software it can handle dynamic environment extremely well. And high accuracy and resolution. There are LiDARs which are achieving very high accuracy and resolution and can provide data within a centimeter accuracy, every point within a centimeter accuracy. So, and those are the greatest devices which you can get right now on the market to get very accurate and high resolution data. And range, of course, different configurations, you will have different range, but typically we are saying it is approximately 200 meters for LiDAR, 300 meters for radar, and 100 meters for smart video. But as I said, it all depends what kind of system hardware configuration will be selected. A couple of examples of applications where flash-eye software perception is used. For example, asset tracking, where we have developed a real-time monitoring for stockpiles and silos, providing mines with accurate insights, measuring volumes of the material which is loaded in either piles or silos, which does not need any action. Hardware is installed only once, software is running in the background, and operator is getting a number on as frequently as operator wants. If this is 1 time per minute, per hour, 1 time per day, it is everything software defined. Object anti-collision, it is about monitoring where the objects are and where people are, sending early warnings about possible collision, possible colliding trajectories, checking also unauthorized access, and still being compliant with GDPR. So can be applied inside the industrial facility and can be applied in smart cities. And another one of the typical use cases, our applications, is vehicle scanning, where our software is used for making basically a 3D models of the vehicles going under the 3D LiDAR, analyzing those 3D models, not only making those models, but analyzing them, comparing, for example, in this 3D model, there on the right side, you can see a dump truck filled with ore with material on it. By scanning empty dump truck while it is coming into the place and scanning filled dump truck which is leaving the place, we can extract the differences. We can calculate how much volume of the material is loaded at this particular dump truck, together with like overload protection, where the material is sticking outside too much. We can send directly early warnings about those kind of situations. And we believe that the perception, the 3D perception, the spatial perception can turn, or is turning actually, infrastructure into intelligent and responsive spaces. And also because of that, the safety will be improved and is improved already in multiple locations. Automatic inspections are enabled by measuring directly three-dimensional data, by understanding how far the object is in real life, not only by analyzing the image, but by knowing exactly where its point in the three-dimensional space is. It allows automatic inspections and spatial awareness for machines. For example, turning already existing machine into the self-aware or spatial aware machine to prevent collisions not only on like 2 dimensions, but basically three-dimensional information. It doesn't matter if the object or if the obstacle will be down on the ground or somewhere high up. Thanks to this three-dimensional perception, it will be detected and avoided, or machine will be stopped in time. Now I will guide you through our modules in the software in our perception stack, and those modules can be used individually, can be used stuck together, creating a scenario for your use case. And we are starting with 3D sensor agnostic layer. And as you will see in the following slides, there is many LiDAR manufacturers, and we are not binded with any of those. We support them all with our software. We believe that great hardware plus great software means winning solution, and there are multiple companies, multiple brands, multiple models of the lidars, and every lidar has its own advantages, and it is great for different purpose. So whenever there is a need for very specific application, we have experience with majority, if not all, lidar manufacturers and models on the market, and we can guide our customers which one would fit the best for this particular application and will be directly possible to use with our software. Another feature is multi-sensor aggregation, where in our perception stack you can combine data from multiple lidars, from multiple models of the lidars, and even from multiple brands of the lidars. As I said, every brand, every model offers slightly different parameters, and it is best to sometimes it's best to combine different, completely different models to get, for example, full coverage or short and long range perception, or very high resolution in specific areas and lower resolution in other areas. The combinations, there is so many combinations which can be applied, and so many reasons why one could want to do that. And our software supports this possibility, allows this possibility to be achieved, to connect multiple lidars in one system, multiple brands, multiple models. It doesn't really matter which brand, which model, which version, which hardware configuration. Then we have advanced filtering. We have developed different filters for different scenarios to eliminate fault alarms, to enhance quality of the measurements in specific scenarios, to be robust for heavy snowfall whenever it is snowing outside, to filter out basically snow data from the point cloud, because sometimes snow will be visible, but the LiDAR will still, and the laser points will go through, laser measurements will go through and get you information which is far behind the snowflakes. Our software is container based and runs only on CPU, and this is something which we hear from time to time, that it is a game changer for some applications, because as nowadays trends are going for more GPU processing, to have huge graphic cards, to have basically like very powerful servers to achieve similar effects and similar results as we can provide just by using very optimized and CPU based processing. And because of that, our software can be deployed very easily on almost any machine, both x86 or ARM based machines. We are running our software on multiple different industrial PCs, which are usually fanless PCs, and they handle great data from high-resolution sensors. So no problem with that. And the next feature, which is one of the module from our stack, is creating a 3D zones with basically without installing any software on your computer, connecting to the computer where our software is running. By using web browser, you can see a point cloud, you can create three-dimensional zones, and those zones on some pictures, some screen recordings, you will see mainly rectangular or box kind of zones, but we are supporting also cones, cylinders, and now also we are introducing curved zones, which is fairly easy to adjust the curvature of different shapes whenever is necessary and then get information from inside the zone. Moving on, more about our modules. Another module which is very interesting is the object detection. And for this, you have multiple parameters which we can absolutely help you to tune according to your needs, but by default they will be quite generic and for majority of applications good out of the box. But you can configure the system to detect small objects, or you can configure the system to ignore small objects and focus on big objects, depends on the scenario. Then we have a classification, and our software is also quite unique in this way that we are allowing our customers to create their own classes, to define their own classes. This is dimensions and velocities based classification. So it is enough that you know dimensions, minimum, maximum dimensions, and minimum, maximum velocity, which object can have and can move. And based on those dimensions, you can define as many classes as you want, which is quite flexible, and moreover, you can detect the objects or filter out the objects based on the classes, get the information about object detection, and you can focus on particular class, on very specific class. So for example, if there is a security scenario and let's say around some facility, and you don't want to have the detection of animals walking around, but as soon as the person will walk by, you want to have the warning or some information about it. It is possible with a correct class definition to tune it in that way. But if you want to detect any kind of motion, if this is a stone, if this is a rock, if this is something even like giving you a couple of points in the 3D data, we also have support for that, and we call it motion and change detection. And then you can define different thresholds on what the system should react, on what thresholds should send a warning. Also, you can define if this warning should be sent right away, if the object is in the zone, or after some delay, because maybe in your scenario you want to allow the object or the item, the points, be inside the zone for a couple of seconds, but if they are longer than a couple of seconds, then you need to get a warning about it. Also, we are providing a lot of additional metadata, like counting the objects, counting the classes, giving information about overall how many objects and what kind of classes are in the field of view of the sensor, or how many objects and what kind of classes are in specific three-dimensional zone, together with extra metadata about every object, dimensions, speed, acceleration, all those additional information. Also, we are providing sensor health, where we are getting information from the sensor, but also we are analyzing the data from the sensor, how the data is changing, and creating additional overview of the system, where we can monitor how many points have been overall within a certain amount of time, and compare, and if we see rapid number of points which disappears from the system, send warning like tamper alarm. Or if we notice that the reflectivity, because this is another parameter from the sensor, from the points, how much light every point is reflecting. If the reflectivity is dropping, we can send also information that there is possible dirt which is building up on the sensor. Also, currently we are working on additional features where we can detect that sensor has been moved. Some sensors are including inertial measurement unit. So then if the sensor includes this kind of information, we are forwarding this information and using this information. But in some sensors, there is no IMU built in. And in this case, we are doing software analysis based on the points received, and we can send information that the sensor has been moved. The system needs to be checked. As I mentioned before, spatial 3D zone shapes, different shapes, cylinders, cones, and curved zones, depends on the scenario, depends on use case. You might want to use different kind of zones. 3D trace viewer, this is something which we also have in our system, where, for example, something or someone will enter the zone. You can record 3D points of this object, basically, which is in the zone, and then view it for further investigation. You can inspect it, you can check dimensions, and so on. We have support for a 2D map platform. Basically, we have a platform which is getting data and which is calibrated with Lidar data, can be calibrated with Lidar data, and show what is happening. What is happening on the basically map with GPS coordinates. At the same time, it can provide converted information about objects with basically GPS coordinates instead of LiDAR coordinates. So you can even think about it that in a way that you can calibrate such a system indoor and get GPS coordinates of the objects which are indoor and moving indoor based on the LiDAR data. But GPS would not be possible to get perception in such places. Another feature with another module in our perception stack is Lidar RTSP stream, and this is used quite frequently in security scenarios where information the user, for example, security guard, they are more familiar with traditional video stream information, but there is, for example, place where they cannot install the cameras. Then it can be still similar stream can be created based on the point cloud. Of course, it will be impossible to recognize who is this person, but on the stream, but you will still be able to recognize that there is a person in the field of view of the LiDAR. We are supporting also PTZ camera control, and this is also mainly for security scenarios, but can be absolutely used in industrial situations as well, where we are getting tracked objects and positions of those objects from the LiDAR and navigate the camera towards those objects for inspection, for evaluation, for basically even combining traditional CCTV systems, which are basically standard monitoring system, together with LiDAR perception. where you're getting LiDAR perception, LiDAR information, quality of the data, and evidence on the camera together with LiDAR. And then also, as I mentioned before, we can provide volume and size measurement. And I mentioned about stockpiles, I mentioned about silos, but also as a part of our software stack, we can provide analytics on about material which is moving on the conveyor belt. So, for example, it can be in the 3D laser can be 3D lidar can be installed above the conveyor belt and scan the data, capture the data, scan material which is moving on the conveyor belt, analyzing it and giving information about like maximum the biggest size of the object on the conveyor belt or the average size of the objects, or send information or warning or alarm if the size of the material is changing, for example. And this is something which some of our customers use it, for example, in mining situations where there is material coming out of the crusher, and then we are analyzing what is the dimensions of the material, and as soon as dimension is changing means that there is something wrong with the crusher, and they can detect the faulty machine much earlier than before. Here a couple of other examples where the LiDAR combined with our perception stack can be used. What is enabled, like enabling autonomous mining solutions. And here we have a couple of solutions where we are enabling automatic rail track inspection for automated trains. So you can imagine the situation when the train is moving on its own within the industrial scenario, and it needs to have information if there is something on the track, if where are the objects, if the track is free to go, together with optimization of train loading procedure. So at the same time, the same system can give you information how much material is loaded on the train, if the loading should continue or should stop, and send reports of the volume basically loaded for entire train for reporting and for further analysis or further knowledge. Industrial clients and or detection with online measurements, as I mentioned regarding the one application is about measurement on the conveyor belt, but also track beds and loader buckets. We can perform the volume measurements and detection of the grade of the material on those places, and advance the volume of measurements of silos as well. This is quite interesting since silos might be small, might be big, might be having a very dusty material, and the LiDAR is much more robust than other techniques for dust in this case, but also together with our analytics, we can provide information when the accumulation of the dust happened on the sensor and we need to be cleaned. Onboard systems, sensors integrated with intelligent traffic systems, basically LiDAR directly with perception on it. We are enabling it because due to the low processing and efficient processing. Government entities, security providers. It is all about smart space monitoring, about GDPR-friendly places, and basically allowing the different kind of traffic, detecting the intrusion in some very specific areas, and so on. And also, another part is machine builders. So our part might be our software, our perception stack might be just a little part in entire huge machine, but a part which will guarantee safety and anti-collision system. And then basically something which was just a machine before might not now be turned into the big robot. Moving on, here you can see basically a basic mapping between different use cases and different modules from our perception stack used for this use case. And you will see this later on because this webinar is recorded. It will be shared with recording later on. You can pause and navigate yourself in all of those use cases. Maybe I will pick just a couple of them to mention. So for example, in a train loading scenario, module number one, which is used, is 3D agnostic layer, where we can combine multiple lidars and different field of view lidars, different resolutions lidars, because this application will need different resolutions in different areas. And then multi-sensor aggregation, as I mentioned, it would be very difficult or close to impossible to cover entire facility with only one lidar, but putting multiple lidars with shorter range, but bigger field of view overall will make this possible. Then another advantage for this use case and another used module is container and CPU-based processing, where everything is deployed on industrial PC and it is basically ready to be installed in the customer's place. Another module is 3D zones, which are used for object detection on the rails, which are used for volume measurements in specific areas. And then and the last module is volume and height measurements. So we can detect overloading of the material, we can detect underloading and notify machine or even like command machine that it can be loaded more or it is enough, it is fully loaded. Then another use case is, for example, ITS, where advanced filtering and segmentation is very in use, together with again container and CPU based perception software, 3D zones and object clustering and tracking, classification and motion detection. And to make it much more user friendly and for everyone to understand what is happening in this kind of, let's say, stretch of the road, it might be connected with 2D map overlay, where all the 3D objects are converted into the 2D points and shown on the map for the let's say supervisor, which is watching the system from time to time. As I said, you will be able to go through those slides on your own pace later on as well. So what we want to achieve with our software is the fast track to Lidar technology, something which you as end user or you as a solution provider might want to integrate into your portfolio quite quickly, and either taking our software as it is with branding of FlashEye software, basically like white label solution, or perception stack is a part of another system, for example, within autonomous system. Or another possibility is our perception is installed on board of the machine or hardware, either on the sensor directly or on the machine, which is utilizing sensor data and taking decisions based on the metadata from our perception. And what are benefits of this kind of approach is reduced time to market. We as a FlashEye have invested already several years and a lot of money for development, and those modules are already ready to go, basically, to integrate with your solution. It is saving costs and years of the development, as I mentioned, and implementing cutting-edge technology, basically in close to no time, where before a lot of development could be required, but now with FlashEye software, it is almost ready to go with, of course, some tuning, polishing, and integrating. And this is a little bit of the technical slide, what is happening in our software and what are the steps within our software. And first we have interoperability layer, where we are combining data from many LiDAR manufacturers. And not only LiDARs, basically any device which can generate three-dimensional point cloud with some standardized drivers. And as you can see, there is so many hardware manufacturers. All of them are already integrated with our software and ready to go. Then we have point cloud filtering and pre-processing. So basically reduction of the noise if there is any, and pre-processing on the point cloud, like cropping the point cloud, narrowing field of view in the software, and so on. Then we have a step where we are doing a segmentation of the background and foreground. So basically our software detects what is the static, which points are representing the wall, the ground, the floor, and what are the dynamic points. And then the next step, based on the dynamic points, we are having an object tracking. And here we running classification, path prediction, and so on. Then after the object tracking, we have zones, rules, and events which you can create in the 3 dimensions. So basically you can create on your own unlimited number of 3-dimensional zones and get information if the object or points are becoming in the zone, and what happens then if you want to get alarm right away, if you want to wait, if you are allowing certain classes or not. And the last step is integration into interoperability layer. And currently we have MQTT, JSON, OPC UA, and WebSocket out of the box. But whenever there is further integration or very specific API necessary, we are willing to help you with that as well. Now I will show you a couple of screen recordings from our software, and this shows some recordings, general what you can do with the software. In this particular case, it's a person, myself, throwing a paper plane. I was playing a little bit with the point cloud, with the data, with the software which can be done, and I have created a class paper plane, and now you can see me changing the bounding box around this classified object from the rectangle to the sphere, and you see now the paper plane as a ball flying in the air. Now I enable different cloud mode view. Previously you were able to see only dynamic points. Now you see static points and dynamic. Another screen recording is from the ITS scenario where the LiDAR was aimed to highway, and you can see we are classifying the objects, we are measuring their dimensions, we are measuring their velocity, giving information from the zone if the zone is triggered or not. Can be used for traffic monitoring, wrong direction monitoring, wrong direction driving, smart cities, and so on. Installation which it can be installed and basically forget and you just get the reports from it. And similarly here, you can see a roundabout and get information how the traffic looks like, where are the vehicles moving the most often, statistical data. Also information about dimensions of the vehicle, which can be used, for example, for maintenance planning. If you see in specific area that there is majority of big, assuming heavy vehicles, maybe maintenance will be required more often. And more on basically there is unlimited number of scenarios. You have to always remember that those are not only points, those are not only triggers from the zones, but all the metadata about dimensions, speed, direction, and so on and so on in real time. And another one, smart cities. This is also for getting information about pedestrians, how the people are walking, if they are crossing the road in correct places, if there is something which needs to be improved, and so. Also, if we think about some industrial scenarios, it can be used for sending a warnings where the people are approaching the machine, either first to the person with, for example, some additional light that the person should stop and don't go further, or even if some of the safety margin will be crossed, to even stop machine at safe time. And those were all the possibilities you can do directly with our modular software, perception software. But also we are innovating. We want to innovate, and we are applying for patents with different ideas. And this is our current patent for portfolio, where you can get information or very specific use cases. And if that is something of interest for you, feel free to contact us to learn more about what we can offer in this area. And yes, that would be it for today. I would like to thank you for your attention, and I'll just to repeat once again that you can build a product together with LiDAR perception right now by using our software out of the box. And what we can provide for you is, of course, LiDAR perception stack, which our entire webinar was about, but also trainings and education and engineering services. If there is a special functionality which you haven't heard from me today, but is interesting for you, feel free to contact us at the email info@flasheye.se. And with that, I would like to thank you for your attention, and hopefully see you after summer on the next webinar.